Let me know if you can't see it. Okay, so hi everyone, and thank you for joining. So today we're going to be talking about Microsoft Defender for APIs, which is part of Microsoft Defender for Cloud. And as we said earlier, my name is Liana Tomescu, and I'm joined here with Lara Goldstein, who is on my team, and we're both working as product managers for the Microsoft Defender for APIs product and Microsoft Defender for Cloud all up as well. So let's talk about API security. Why is it relevant and why right now? So what do we know about API security? First of all, we know that APIs are ubiquitous, which means that they are everywhere. And we know that 83% of internet traffic is now driven by APIs. And an additional thing is that traditional API security measures are inadequate. And in fact, 90% of web applications will expose attack surfaces via APIs, even with the traditional API security measures. So we need something else. And then APIs are also the most frequent attack vector as well. And in 2022, there was a 7 times increase in API attacks in the last 12 months. So basically, APIs are growing, they will keep growing, and that means that attackers will try to target them, and they actually have been targeting them already. Unfortunately, these are some examples of API attacks that have occurred in the last few years. And the way that I think of it when I see this slide is that all of these attacks are all exposure in the millions. So exposed data of 700 million users of LinkedIn in 2021, or last year in November, Optus also having impact of over 10 million users. And then the impact isn't just to the amount of people that are that we have data exposed for, but it's also how much it costs in actual fees and breach recovery afterwards, 140 million US dollars by Optus. And of course, there was also an attack earlier this year as well. So, and we know that the average cost of per data breach is 4.35 million, and it will keep increasing. So there are a lot of API attacks that have occurred, and they will keep occurring. So we need to find a way to better protect our APIs. And then what does that mean? How can you actually protect your APIs? What are the things that you need to protect your APIs? So there's a few things. These are just kind of a very brief summary. First of all, are your APIs configured securely? So do you have the correct, first of all, do you have authentication for the APIs? But also, is it a secure type of authentication? And then how many unused APIs exist in your cloud environment? If there's legacy APIs and they're there, maybe you should consider getting rid of them. And, also if they're exposed to the internet as well, that's another kind of red flag. And then can you detect an active API exploit? So if there actually was to be an API attack on APIs, would you have something to detect that with? So this is where Defender for Cloud comes in. And basically, Defender for Cloud is part of Microsoft's CNAPP solution, which is Microsoft's Cloud Native Application Protection Platform solution. And basically, Defender for APIs is part of Defender for Cloud. So Defender for Cloud and Entra Permissions Management makes up Microsoft's CNAPP solution. And then Defender for APIs is one of the capabilities that we have within Defender for Cloud. And it's when you'd originally think of where is Defender for APIs, where does it sit within Defender for Cloud, you would think that it sits in the cloud workload protection, alongside all of the other Defender for Cloud plans that we have, Defender for storage, Defender for servers, Defender for containers. And that means that we're looking to detect any threats in your environment, so any threats on your APIs. But actually, Defender for APIs doesn't fit just that bucket. It also fits, it's also part of the cloud security posture management pillar as well. because we provide you with recommendations with best practices to improve your API security. And then we also are part of the DevSecOps capability as well, where we're able to protect your APIs that are, if you're trying to deploy APIs that go to that are in your GitHub or in Azure DevOps, and you have ARM and bicep files, and you're trying to deploy your APIs from there, then we're able to detect security misconfigurations with that, and that is with our Defender for DevOps plan that is within Defender for Cloud. So that's where Defender for APIs sits, but let's talk about Defender for APIs now specifically. So the first thing that I'll say is that currently with Defender for APIs, we are able to protect APIs that are part of APIM, which is Azure API Management. So if the APIs are sitting behind an Azure API Management, then we are able to protect them with the following capabilities that we have on the screen there. So the capabilities are, first is classifying and understanding the security posture of your APIs. And what that means is that the very first thing, and often when I talk to customers about this, if we're talking to the security person, they don't know which APIs need to be protected. They don't know about the API side of the house. And it's very important for the security person to be able to understand, to know which APIs are there, to classify them, to understand what's going on about them. That's a very first step to really making something secure, is knowing about it. And then once they know about it, what's the next step? So that's hardening the API configurations. And that involves basically getting best practices. And these are through the recommendations that we have in Defender for Cloud. So you receive these best practice recommendations about how to harden your APIs and also your APIMs, which is Azure API Management. Yeah, and then we've also got the prioritized risk remediation step as well. And this is basically, this allows you to be able to do your own proactive threat hunting with APIs that we have through our integration with Defender CSPM plan as well. And then last but not least, so what we've done now is we've understood the APIs, and then we've done the best practice we've followed the guidance to harden them. And then last but not least is, what about if there was to be an attack? Then we're able to monitor and protect the APIs against attacks in runtime as well. So if there is a threat, we will detect it and we will alert you about it related to the API. So in the very first pillar that we have, so this pillar is classify and understand the security posture of your APIs. So just to know, what does that mean? What do we actually give you with that? Well, the first thing is we give you this unified inventory. And Lara will show you in the demo in a little bit. But basically the unified inventory shows you all of your APIs. So it shows you at the API level, you can see kind of a broad overview, but then if you select an API, you're also able to see at the endpoint level. So this is the screenshot that we have on the screen. This is where you're able to see different endpoints, see what kind of an endpoint are they, post, get requests, and so on. You can see information like when it was last called. And then, was it called in the last 30 days? If it hasn't been called in the last 30 days, it will get flagged as something that you should consider removing. Best practice would be to remove it. And then, is there authentication as well? So we have a few forms of authentication that we are able to detect for. If when you're calling the API, our system has detected that you are actually using these best practice authentication. Apologies if you can hear the background. I think there's an ambulance going past. Okay. Yeah, so basically with the authentication, if any of the main authentication mechanisms that we have that are safe are triggered, then this will detect that it is authenticated securely and it's all good. And then we have external traffic observed, which basically says, has this been called externally from the internet? And it tells you when that the last time that was. And last but not least, there we've got our data classifications, and our data classifications actually comes from the default classifications that are part of Microsoft's classification engine. So they're the default classifications that we have with Microsoft's classification engine. Yeah, okay, so for the next slide there. So this is part of our hardened API configuration. So those best practice recommendations that we have for you to secure your APIs. So we have our API hardening, and that is, you can see recommendations like we have on the screen there of API endpoints in Azure API management should be authenticated. And then it gives you steps how to remediate this. And then it also gives you all of the resources that are actually the ones that they're all of the API endpoints that don't have the authentication in place. And the authentication as well, in this case, because I mentioned it a few times, the authentication is checking for subscription keys, JWTs, and client certificates as well. And then we've got our API risk prioritization. And again, I mentioned that one, it's based, it works alongside our Defender CSPM plan, and it allows you to check do your proactive threat hunting through our Cloud Security Explorer capability. So I wanted to tell you about which of these, these are live now, which recommendations we have that are associated with APIs. So we've got two types. We've got API recommendations, and I'll tell you in a minute about the APIM, so API management recommendations, but for the API recommendations, so the first two are the onboarding recommendations that Defender for API should be enabled. Azure API Management API should be onboarded to Defender for APIs. And then we've also got the API endpoints that are unused in the last 30 days should be disabled and removed from the Azure API Management service. And then we've got the API endpoints in Azure API Management should be authenticated that we have talked about. And then the other type of recommendations that we have are our API management recommendations. And these ones are looking at recommendations for how to secure your API management. So as an example, the second last one there, API management minimum API version should be set to 2019 or higher. API management calls to API backends should be authenticated. API management APIs should only use encrypted protocols. So we have these recommendations that are looking at both the API, at the actual API level, but also at the API management level. Okay. And now we have our third pillar. So once again, we've talked about understanding all of the APIs, knowing what's the status on all the APIs, what's the data classification associated with the APIs. We found out about our recommendations that we have, how to harden your APIs. And that's on the proactive side. And now this slide is actually looking at the reactive slide of if there was to be an attack, how would you know about it? And in this case, we have OWASP API top 10 coverage. So we would be able to detect OWASP API top 10 threat detections. So you can see an example of it there on the screen. Suspicious payload spike in API traffic to one of your API endpoints. And we have basically two types of detections, machine learning based detections, and we also have rule-based detections as well. So you get all of this kind of information, you get alert description, you get alert details, general information about what was going on, information about how to take action on them. And then if you did want to take action, you're also able to integrate with Microsoft Sentinel. So after you've done your investigation, you can integrate with Microsoft Sentinel or with other SIEMs as well, so that your SOC team is able to investigate these APIs and take the next step. Okay, and here are a list of some of the APIs detections that we have. And once again, there's two types of APIs, and these are now public. So the bottom three there, they're the rule-based API attacks. So access from malicious IP address, access from a suspicious user agent, and access from a Tor exit node. And these are very helpful. Lots of customers say that, like, they need this. And then we've also got the machine learning based detections. So the difference is that the machine learning based ones, well, they've got the machine learning algorithms. There's also several of them also have some rule based capabilities as well. So if there was to be a super unusually large detection, then it would trigger, even though there is an up to 30-day learning period as well for the machine learning based algorithms. So it's up to 30 days for the algorithm to determine what is normal in your environment, and then it will detect alerts. It will detect the threats afterwards. So just to kind of quickly go through these. So basically, the first one there is detect spike in API requests to a single endpoint. So what that means is that you've got one single endpoint. I always show it like this. You've got one single endpoint, and you've got a spike of requests going to this one single endpoint, and that could basically signify like a DDoS attack or a botnet attack. So that's one that we're able to detect. And then the opposite of that, what I always think of as the opposite of that, is basically detecting a spike in the number of endpoints called by one single identity. So one single identity is calling lots and lots of endpoints. And that could be because of compromised credentials. And we detect for that one too. We have the detect unusually large API payload and latency. And again, there's a machine learning based portion of that and a slight rule based portion as well. And then we also have detect parameter enumeration. So for this one, it's say, for example, you have an API that is with the following URL, shopify.com/store/1/user12. And this could be a legitimate user, their user number 12. But then they go to change the ID in the URL to be 13 or 14 or 15, and then they are able to capture all those other users' data. This is something that would be triggered by this alert, by this detection. So an alert would be called out for this one. And then we also have the last one there that we have is detect unseen parameters and parameters of anomalous types, which deviate from the historical observations, which are more likely to be malicious kinds of attacks. Yeah, so this is my portion of it done. So now I'm going to actually introduce you to Lara, who's just going to take over the last two slides, and then we'll show you a quick demo as well.
Yes, thank you, Liana. So there have been some questions in the chat already about what's the story with Azure API management and application gateway, web application firewall. So I'm glad those questions have been asked because we're going to start discussing that within these next 3 slides. So Defender for APIs has prioritized targeting API management solutions, as the customers that we talked to have been heavily adopting these solutions to manage their APIs. Especially our Azure customers are using Azure API Management Service. And when you think about securing your APIs, you do need a defense in depth strategy, and you can get this by combining Azure API Management, Defender for APIs, as well as network security services like Web Application Firewall on top of Application Gateway. So first, APIs are continuously subject to a variety of different attacks and threats, such as broken user authentication, data exfiltration, code injections, and DDoS attacks. By combining Azure API Management, Defender for APIs, and network security solutions, you can get comprehensive protection for every API with security posture insights, runtime threat detections, and more. So for security posture, Azure API Management will accept all requests from client applications and forward them to the respective backend services, which lets the API providers focus on their backend architecture without having to impact their customers. It's going to verify authentications, usage quotas, rate limits, and it can transform requests and response and emit logs for metrics and metrics for monitoring. Defender for APIs comes in here because it can help with protocol management, identity management, certificate management, basically giving visibility into if any API endpoint is authenticated, and giving additional visibility into where we've detected sensitive data, externally exposed APIs, or inactive APIs. Next, we can go into the runtime protection. So Azure API management can help with schema validation and ensuring that caching is enabled for increased protection against denial of service attacks and handle the authentication mechanisms, as well as enforce rate limiting and IP address filtering. It can also produce insights with Azure Application Insights or Azure Monitor. And then Defender for APIs is going to complement these capabilities by extending the basic security that Azure API Management already offers with machine learning and rule-based threat detections that also produce insights about whether the API endpoint is exposing sensitive data. All of this information, regardless of if it's coming from Azure API Management or Defender for APIs, can be streamed to Microsoft Sentinel or any other security incident event management system for advanced correlation and response capabilities. And then lastly, by adding in perimeter protections with network security solutions, you can take API protection to the next level. So this allows you to achieve layer 4 through 7 threat protections with Azure Firewall and Azure Web Application Firewall, and benefit from many of the native security features to isolate your API endpoints within your virtual networks. You can also protect against DDoS attacks with Azure DDoS Protection. By using all of these solutions combined, you would get end-to-end lifecycle protection for your APIs. So how do we work together? This slide, it really focuses on the better together story of Azure API Management and Defender for APIs. Azure API Management is giving customers a central management plane and gateway to publish their APIs, enforce policies regarding how requests and responses are transformed, whether authentication is configured, monitor traffic going to and from API endpoints, and overall have security governance. While there is a base level of security that is offered by API Management, Defender for APIs builds upon this to prevent, detect, and help you respond to API security threats with the broader cloud security context. It gives admins a central view of all of the API collections and endpoints hosted within Azure API Management Services. It searches for risk factors such as inactive, unauthenticated, externally facing APIs, and APIs that transmit sensitive data. And with all of these insights also flowing into the broader Defender for Cloud platform, you can begin to prioritize risks, protect APIs against the OWASP API top 10 vulnerabilities with machine learning-based behavioral anomaly detections that understand the normal traffic passing to and from each endpoint, in addition to role-based protections. Overall, by using these solutions together, you can get a single pane of glass to enforce policies, monitor threats, and ensure you reduce your API attack surface as much as possible. And then this last slide here is another better together slide around the whole lifecycle for APIs and protecting them end to end. So Defender for APIs is discovering threats and misconfigurations, detecting active attacks, and then allowing customers to mitigate these threats by integrating with solutions like Azure API Management to define policies, or Azure Web Application Firewall to block traffic coming from specific IP addresses if their endpoints are under attack in any way. You can use workflow automations in Defender for Cloud to achieve this sort of integration, better together story, and ability to tune your policies to ensure your APIs are secure. In this fast-paced world of digital transformation, an integrated approach to API management and security can provide the necessary edge that you would need to stay competitive and secure. So that's enough for the slides. I know there were just 3 slides that were all very similar, but we just really wanted to drive the point home that this isn't a do you use API management, web application firewall, or Defender for APIs. It's you want to use all of them combined to have that full lifecycle protection. So now for going into the demo, Defender for APIs is going to be part of the overall Defender for Cloud platform, which is a cloud-native application protection platform, combining cloud security posture management, cloud workload protection, and DevSecOps. When you want to enable the Defender for APIs plan, there are currently 2 steps that you need to follow. So first, in Defender for Cloud, you would navigate to Environment Settings, select a subscription of choice, and then under the Defender plans, this is where you would actually be able to turn the status of APIs on. So in my environment, it's already on. If it were off, then I would just switch it to on, click save, and then Defender for APIs would be enabled on the subscription. The resource quantity here is going to be how many Azure API management services that I currently have in my environment. But even though this plan is on, I can see that there is an action required warning here. Here it's telling me that the onboarding isn't complete yet, and I need to navigate to a recommendation to onboard individual APIs over to Defender for APIs. Because we are currently requiring customers to onboard each API collection separately to Defender for APIs so we can begin to give them security coverage for those API collections. So in order to enable that, I would then go into the recommendations view within Defender for Cloud. Here I'm going to type in API, so I can filter just for API related recommendations, expand this screen out. Let's move this over, and I can see this recommendation saying Azure API Management APIs should be onboarded to Defender for APIs. So I'm going to click on this recommendation. When this opens up, I can see my unhealthy resources, these unhealthy API collections that have yet to be onboarded to the Defender for APIs plan. I can also see all of my healthy API collections that have already been onboarded. To onboard these APIs, I'm going to select them. I can select everything at once, or I can just select one at a time, and I would click the Fix button. And this would go ahead and it would onboard the APIs over to Defender for APIs so we can begin to produce security insights and protect against different sorts of attacks that we are noticing. So let's pretend that I onboarded these APIs. After I onboard these APIs, I'm going to see some new recommendations popping up within Defender for Cloud. As Liana discussed, we do have different sorts of recommendations for API management services and for the actual API endpoints. So for the API management service recommendations, I may have one here saying that API management services should use a virtual network. This is going to be provided out of the box with Defender for Cloud free foundational cloud security posture management because it's on the API management resource level and it's built on an Azure policy behind the scenes. So for these sorts of API management service best practices, I'm able to see all of my unhealthy API management services, view different sorts of remediation steps to make sure that my API management services use a virtual network so I can connect to them more securely and I don't have to worry about them being accessible from the internet. And I can see how exactly I can configure that through the remediation steps. Some of the other API management related recommendations, we might have one here saying that the API management minimum API version should be set to 2019 1201 or higher. Here I can see why this is a recommendation, because it's saying I want to prevent service secrets from being shared with read-only users, so I should update the minimum version here. I can see the different remediation steps and my unhealthy resources. What's nice about this recommendation in particular is that since it integrates with Azure policy, there's actually the option to enforce this deny effect on the Azure policy, and that would prevent any new resource, any new API management service from being created if it's not setting the minimum API version to 2019 12.01 or higher. So if I select this deny, that can be enforced on the subscription level, the management group level, and no new resources would be allowed to be deployed if they're not following this practice. And I can also prevent any resources from moving to healthy to unhealthy, so they wouldn't be able to change the setting after the fact. Those are examples of the API management service recommendations. But when I think through the API specific recommendations, this is where I can see something like API endpoints in Azure API management should be authenticated. So here the unhealthy resources are all going to be API endpoints. And for each endpoint, I can see the collection that it's hosted in, the Azure API management service that it's hosted in, and the underlying subscription. Here, all of these unhealthy resources are APIs that don't have any sort of authentication configured, which means that there was no subscription key, JSON web token, or client certificate configured within Azure API management, and that successful 200 requests did occur without noticing any sort of authentication present. So that's very helpful for our security admins to understand, knowing that users are able to authenticate to these API endpoints without any of these configured authentication mechanisms. This insight is also available within the API Security Blade, which is in Workload Protections within Defender for Cloud. From here, I have the API Security tab, and I can open this up, and now I am in a dedicated page just for API Security. So what's really nice about this, first of all, is that it is bringing an inventory of all of the API collections that you have hosted across all of the API management services within your organization. And this is very unique because it's been very hard for security admins to get this sort of centralized visibility in the past. So being able to see all of these APIM services within a single place has been very helpful for our customers, and we've received a ton of great feedback around that. But that's only just giving you visibility. We haven't even talked about some of the security insights, because with this inventory, you can also see the base URL of the Azure API management service, the discovered column that shows the API management service that the API collection is hosted in, the number of API endpoints within this API collection, how many are active, meaning have we seen any traffic in the past 30 days, how many are authenticated, have we seen any sort of external traffic, and are there any sorts of sensitive data classifications? If I want to learn more, I would actually click on one of these API collections, and then I can drill down. So now I can see all of the API endpoints that belong to this API collection, and I can see each insight for every single API endpoint. So first we have the endpoint name and the actual call that's used when accessing this endpoint. So I have some that are used for get, then I have some which are actually updating or adding information through the post method. So I can see all the HTTP methods here. I can see the last call date for each API endpoint. This is used to help benchmark the insight for whether they are active or inactive. For cloud workload owners and security teams, this insight demonstrates which APIs within the organization haven't received traffic for a period of 30 days and these may be APIs that should be deprecated and removed from the Azure API management service, but they were accidentally left there for some reason. This is really common in the case of new versions of APIs being released, with the previous version still left active, and they may not be receiving the most up-to-date security patches, which could bring risk to an organization. For the authentication insight, where for any API that's published within Azure API Management, the insight is assessing the use of authentication through subscription keys, JSON web tokens, and client certificates that have been configured within API Management. If none of these are present, then they're going to be considered unauthenticated. Next, there's an insight about if any sort of external traffic has been accessing your API endpoints. So here we're looking to see if any APIs are exposed directly to the internet by seeing if there were successful calls from IP addresses in a non-private range as defined in RFC 1918. And on top of all of these basic insights that we have, so you can just understand where your risks are with your API endpoints, we're also showing you which APIs expose sensitive data. APIs frequently tend to expose sensitive data, including personally identifiable information, which makes them a prime target for attackers. So by classifying these APIs, we can enable organizations to prioritize the APIs that are both most important to secure for hardening purposes and to remediate post-attack. So here in this submit session API, I can see that there is sensitive data that is being posted to this API endpoint. And alongside this insight, I can also see that it's an active API, it's unauthenticated, and we accept external traffic. So if there's any API that I want to configure authentication for first, or maybe make sure external traffic can't get in if it's only supposed to be internally facing, it would be this submit session API endpoint. And here I can see if I do have any sort of outstanding recommendations on that API endpoint. If this loads, it would show me a resource health blade, and I would be able to see that the API has the recommendation that it should be authenticated properly. And then the other outstanding recommendation that would be present would be that it should be onboarded, but that would be marked as healthy. And I would also be able to see the sensitive data classification within the resource help blade. I'll try to open that one more time, but it doesn't look like it's wants to work right now. My portal has been having problems all day, which is why I have some of these tabs open already, just in case something like this happened, because I wanted to make sure I can still show some value, especially with the alerts. So Defender for APIs, as Liana mentioned, it includes machine learning-based detections and rule-based detections. For the rule-based detections, those are going to be the same in every customer environment. We're looking to see if suspicious user agents are accessing your API endpoints, if there are requests coming from IP addresses that are known to be suspicious based on Microsoft Threat Intelligence data, and if any sort of Tor exit nodes are accessing your IP addresses in an attempt to mask the underlying IP and maybe perform some sort of attack. But then we also have the machine learning based detections. So we include runtime monitoring support for a set of these machine learning based detections that assess APIs against the OWASP API top 10 risks, and they include detections for broken authorization, broken authentication, injection attacks, excessive data exposure, and lack of rate limiting. And these are all available within the security alerts blade within Defender for Cloud. So if my portal were working perfectly, then you would be able to get there through security alerts, and we'll see if this opens, but it would be present within security alerts. Thankfully, I have this specific alert open already. And within this alert, we can see that there was an unusually large payload response transmitted between a single IP address and an API endpoint. So here, this is abnormal for a variety of reasons, and we're going to tell you why within the alert. So we're saying in the past 30 days, this IP address has made API calls to the endpoint with an average payload size of 110 kilobytes. And the standard deviation for that was around 7.4 kilobytes. This event of interest is different because the payload size was 1,255 kilobytes, and that's several standard deviations higher than the observed mean of 110 kilobytes. So this is why we believe it is abnormal and why we're throwing an alert for it, because we understand the historical behavior of how this IP address interacted with your API endpoint, what the normal activity was, and why this is something that isn't normal for this IP address and for your API endpoint. So in this event, as I said, the payload size was 1,255 kilobytes, and it was also successful. So we can see that the status code was 200 here, and I can just get another field to understand the payload size. So all of this information, when it goes over to a SOC team, would be incredibly valuable because they are able to see why this alert was actually triggered. So if it was something that was expected, if they know that it's valid activity, they would be able to determine that through the information that we're providing. But at the same time, if they determine that this isn't normal, this can be a result of an injection attack or an attempt to exfiltrate sensitive data or any sort of data from this API endpoint. And in that case, the SOC team would be able to correlate this activity with other logs from your cloud environment to see what data it was accessing, what sort of information was transferred, so they can know right away if they need to block this IP address through web application firewall, or if there's any other activity that they need to do to ensure that this API endpoint is as secured as possible and it's no longer vulnerable to this threat. So that sort of action would be very important for the SOC team to know and take immediately. And thankfully, they would have all of this provided to them via this alert, and all of the other machine learning based alerts that we're providing. We're always going to let you know why it differed from historical behavior and what you need to do about it, which would be present in the take action blade. We're going to say that you should check if the IP responsible is benign and it has valid business reasons. If it doesn't, consider any sort of external events that could explain why the payload size was so much larger. Then you want to see any other alerts that are affecting that API endpoint that may help contextualize the spike. You'll want to inspect the contents of the API call to make sure that sensitive data wasn't being exfiltrated. You'll check for the return status code. In this case, we already saw that it was 200, which does indicate success. And then if it is determined to be malicious, you want to block or limit the IP address. You may want to limit it from only being accessed to specific IP addresses, especially if you don't want to leave it wide open to any other IP address. I can also see that there are 15 more alerts that are affecting this resource. I'm not going to click all right now because my tenant isn't working properly. It has nothing to do with Defender for APIs, by the way. This is all entirely my own fault. But if it was working, I would be able to click on this and see the other alerts. And I can also prevent future attacks by remediating the recommendations. In this case, this API endpoint is inactive. We haven't seen any activity in the past 30 days. So this is an API endpoint that we should probably disable and remove from the API management service, especially if it doesn't need to be there anymore. If we released a newer version for it or something along those lines. You can also trigger automated responses. This works through Azure Logic Apps, a workflow automation tool, and that would go ahead and maybe take action to create a policy on your web application firewall to block traffic from that IP address, or to block similar sorts of requests that are requesting way more data than should be allowed. And these events can also be streamed with Sentinel, so you can take action from Microsoft Sentinel or any other security incident event management system of your choice. So that is what I have for the demo. Thank you all for your patience and staying with me, even though I was having some tenant problems. But now we have some time for questions, so we're happy to take those.
Great. Thank you, Lara. The team's been great with answering questions. We do have a few. First is Azure API management a prerequisite for Defender for APIs?
Yes, Azure API management right now is a prerequisite for Defender for APIs because we're currently supporting APIs that are published within Azure API Management Service.
Great, thank you. The next question is, are all SKUs of Azure API management supported?
So the consumption SKU isn't supported at this time, but developer, basic, standard, and premium SKUs are supported. We are also not onboarding APIs that are exposed using the API management self-hosted gateway or that are managed using API management workspaces. And we are discovering and analyzing REST APIs at this time.
Great, thank you. The next question is, does Defender for APIs integrate with Sentinel?
Yes.
Yeah.
So yeah, Liana, feel free to take that one.
Yeah, no, it's perfect. Yeah, I think as we said earlier, yes, you can basically get all of the alerts that we're getting from Defender for APIs, so all of the threat detections that you've received alerts for, and you can get those sent over into Sentinel, where you're then able to take the investigation to the next stage, we're also able to get them to correlate into incidents as well.
Great, thank you. Next question. Is there a way to get a centralized view of all APIs we expose and consume from all apps and services?
If they're published within, oh yeah, sorry.
No, go for it, go for it, Lara.
If they're published within Azure API Management Service, then yes. If they're not, then not at this time.
Great. Next question is, will the SOC analyst need to do a manual correlation of the alerts, or will MS use this Defender's alerts and pre-correlate them with other signals into incidents?
Yeah, so that's kind of similar to the incident one. So they will get correlated.
Great. And then the last question we have is, for any detection looking at client IP, if we have gone through a WAF before Defender /APIM, the client IP address will always be the WAF. Can this use an XFF header to detect the client?
Interesting. So you've gone through a WAF, the client IP. I believe we would still be able to detect the client IP address, especially if it's a WAF like Azure Web Application Firewall. We would have a much better integration story to tell there. So that would probably be more positive. Otherwise, we may be just showing you the client IP address of the WAF. If this is a valid need to consider, we would love to stay in touch about this request and see how we can support you in the future. And then I see some of the other questions in the chat. So the cost of using Defender for APIs, currently it's free in public preview. It's not always going to stay free, but right now it is free until we go generally available. So this is a great time to try it out, understand the capabilities. And then before we do go generally available, we will be making the cost clear. It's a plan within Defender for Cloud. All of the plans within Defender for Cloud are pay as you go. So you are able to choose which resources you want to protect, like APIs or servers or whatnot. So I see a question saying need a separate license. So technically you do, but it's all part of the Defender for Cloud platform. Let's see some of the other questions that we have here. So how long is the learning period to determine the baseline? And I see Fasafi has already answered, saying 30 days. So for the machine learning based detections, these can take up to 30 days to actually build the baseline of what traffic is considered normal. It can be quicker than that at some points, not always, but in general, you'll see the most value after 30 days of us learning the normal activity. Liana, do you see any questions that you want to call out?
I'm having a look now. Is there anything else that I see?
So throttling, I see regarding throttling and quota limits, IP address filtering, isn't that already a feature of Web Application Firewall? Yes, this is part of Web Application Firewall. Azure API Management also has some support for throttling and quota limits. But in general, these two services work really well together. And then Defender for APIs is going to take it to the next level by actually providing API-specific threats that are tuned to each API endpoint that you have. So while web application firewalls are amazing solutions, they are not able to dive as deeply into each specific API endpoint normal activity because it has to protect against such a wide range of requests. You want as low latency as possible. So by having Defender for APIs, you can take it to the next level now that we have this dedicated protection meant just for your API endpoints, which is why you want to use these solutions together. And when you do detect a threat in Defender for APIs, maybe regarding a suspicious IP address accessing your API endpoint, that's when you would integrate with an API management service or web application firewall to set a policy to block that IP address.
Perfect. And I see there's two quick ones as well. So what is the role assignment? So for this one, and I also put it in the, I answered this question also, you need to have either, so to onboard Defender for APIs, you need to have either owner or contributor to the Azure subscriptions, or else, to the Azure subscriptions resource groups or to the APIM. And then otherwise, you need to have security admin in order to to see everything in Defender for Cloud and to basically onboard. And if you don't have security admin, security reader will also let you see some of the recommendations. And then the other one that we have there is around the security checks on APIs. How are they consumed? So the traffic for the security checks are based on the diagnostic logs, and we don't store payload traffic for longer than 48 hours as well. So that's a question we sometimes get. But otherwise, I think these might be most of them. Yeah, great. I think this is most of them.
Awesome. Well, with that, I'd like to thank you, Liana and Lara, for being our guests today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/securitycommunity. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We'd love to hear your feedback on how we can improve these webinars. Please take a minute to submit your webinar feedback at aka.ms/security-webinar-feedback. Thank you, and see you next time. Goodbye.
Thank you, everyone.